Yeah, basically to start us off. So today the plan is to just like work through problems today. We're not really gonna go in depth into like how OOP works and stuff like that. If you're interested in that kind of stuff, then I would recommend coming to the Saturday lecture. We're going to go more in depth into the concepts and like how OOP works and like why we need it, stuff like that. And then obviously there's gonna be like a full like step-by-step breakthrough of a problem towards the end. Today the plan is just to basically show you guys how to like when you're given like a problem, like how to approach like designing a solution to it. So we're not really gonna be writing necessarily any code today, but more or less just kind of organizing our solution to decide like, oh, what do I need a class for? What do I not need a class for? What can be a property? What cannot be a property? Stuff like that. And then when you have like an inheritance structure where you need to put stuff like on that structure and things like that. So the plan right now is to have 3 problems. So Rena, Kate, and I will each walk you through one problem. And if you guys have any questions, feel free to ask along the way. We're all happy to answer them and all that stuff. So basically, to start us off, I'm going to go here. It's my first time using Zoom Whiteboard, so I apologize if this doesn't work out as well as I hope it works out. But for this first question, we're going to start with something a little bit easier. I'm going to like assume like you're a programmer and you've been asked to write a program that kind of simulates like an aquarium or a fish tank or something like that, right? So we're gonna basically set up a structure for how we would go about solving this, what would we use in different classes and things like that. Obviously, as you know, a big part of object-oriented programming is the objects, and when it comes to an aquarium, I'm sure there's like a few big objects that you can think of, obviously like the animals. So if you have any suggestions, we can think of like 5 or 6 animals that you guys would find in an aquarium. Anyone wants to name them off?
Yellowfish. Turtle.
I think I heard like 3 things at once. I think Tim, I think I saw your name first. What did you say?
Blowfish.
Blowfish?
Clownfish.
Yep.
I heard clownfish. I'm gonna say pufferfish. That's all right. Anything else?
I think I heard turtle.
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 Anyone else?
Cephalopods, squids.
Squids. Yeah, I think we should go for like species instead of. I guess is cephalopod. I think it's a genus, right? So I don't know.
Yeah, it's up there.
Sea
Anything else?
urchins.
Yeah, penguin.
Shark, dolphin.
I heard dolphins.
The seahorse in there?
Seahorse. And then let's think of like maybe 1 or 2 more. Just go spell clownfish wrong.
Jellyfish?
And you gotta spell dolphin right also.
Got the
I
L.
forgot the L. Thank you. How about we go with something that's not a fish? Anyone think of something that's not a fish?
Penguin.
Shark?
I feel like sharks are technically fish, right? They're like a subspecies of fish.
Oh, was it whales that aren't fish? I mixed them up.
Yeah,
Like an eel or something.
I think eels are also technically fish, but we can include eels too.
There's some algae.
Sea cucumber.
I think sea cucumbers are also cephalopods.
What about a penguin?
Penguin,
Polar
that
bear.
works. I love penguins. Okay. So obviously we'll stick with this for now. We have 1, 2, 3, 4, 5, 6, 7, 8 animals ish. Okay. And just for fun, I'm gonna add my personal favorite animal at the aquarium, which is the sea lion. I don't know why, I just love sea lions. That's just me. But obviously, so let's say, so this is our aquarium. It has these 8, animals in it. And we want to go about, writing a program that's going to kind of simulate these animals in that environment, right? So obviously we can start off with like one, big overarching class, which is called aquarium, right? This is going to handle everything from like actually creating the environment, stuff like that. But in the aquarium, we have all these fish, right? All these animals, okay? And then when approaching this, to make this easier, we want to do something. I don't remember if Unker covered this in class or not, but like it's called abstraction, where you basically want to break up your problem and do like a set of smaller sub problems to kind of make it easier for you. So we could code, 1, 2, 3, 4, 5, 6, 7, 8, 9 individual classes, right? But if we broke this up into like an inheritance structure, it's going to make it a lot easier for us, and it helps get rid of redundant or repetitive code. So we can actually program this a lot faster and a lot more efficiently, as well as making it like a lot more readable as well. Because when obviously it's more easier to understand things if they're more organized. So when we're looking at this list of these like 9 animals, what is one way you guys think you can split them up? I'm sure there's one big obvious way everyone can think of.
The species.
Yeah, obviously, right? But like you split them up into like fish, mammals, reptiles, right? Stuff like that. So we have the mammals. So we'll have our mammals, then we'll have our fish. Oh, whoops. And then we have our reptiles. For the sake of argument, I'm just going to consider a squid a fish. I technically don't think it's a fish, but that's whatever. So inside this, can I not edit this? Does anyone know how to like edit the boxes that are already there? Can I not do that? Does anyone know?
A double click usually works for me, but
I am double clicking.
just rewrite it.
Whatever else, right on top. Okay. Also 2 M's? I think so.
Yeah.
Okay, so then what is something that is shared by, so like, right, so the mammals in our list right now, it's the dolphins and the sea lion, right? So what is like what are some properties that are shared by like all mammals in our aquarium?
They all give birth and they don't lay eggs.
They
What
don't
about
lay eggs.
platypus?
Yeah, but like technically we don't have a platypus in our aquarium, so I guess for this certain scenario, I guess it wouldn't matter. If we had a platypus, we probably have to define our properties differently, right? But some mammals, right, they don't give birth. They don't give birth through eggs. What else?
They all have hair. They don't have fur. They technically have hair.
Okay. What else? I don't think of one other thing that they all have.
They all have to breathe oxygen, right?
That's true. Okay. So now if we want to, oh, now it's like overlapping. This is kind of like whatever. But then I erase. Oh, there we go. That worked. I'm gonna erase these 2 for now. We'll come back to them later. So then, if mammals is our parent class, what are the child classes going to be in this case? We have 2 of them, right?
Dolphin.
Anyone tell me?
And
Dolphin, right? 1. Dolphin is 1. And then what's the other one?
Sea lion.
Sea lion, obviously. And then, what properties do we want to put in this dolphin class?
Food source.
Sorry?
What they eat, like a food, a source.
Okay, generally, actually, I don't know. Possibly. Generally, when it comes to properties versus inheritance, this is something else that I think makes it easier to like think about it. Is like if something is a property of something, you generally want to use the words like has a, right? Like a dolphin has a blowhole, right? Or a dolphin has flippers, something like that. But if you're using something like if it's an is a relationship, that's more inheritance, right? A dolphin is a mammal, right? A shark is a fish, stuff like that. So when you want to think of properties that belong to a dolphin, you kind of think of things that like a dolphin would have. Does that make sense? Just like your nouns. Right? So can anyone think of 1 or 2?
They got fins.
Tail.
You have a tail. Okay, so when it comes to a tail, is that something unique to a dolphin?
Not quite.
Sorry, did someone, Rena, did you
No,
say
no,
something?
it's not.
It's not, right? So technically, like, you can't really put tail in mammals here, right? But let's say, for example, I don't think sea lions have tails, but let's say, for example, sea lions did have tails, right? For example, then technically, couldn't we put tail in our overall like animals class up here? Because everything can inherit that tail property, right? Because everything has a tail. That makes sense? You guys get that? Obviously, in this scenario, sea lions
Yes.
don't have tails, but we're imagining that they have tails in this scenario. So
Just to clear it up, according to SeaWorld.org, sea lions do have tails. So
they do have tails. Okay, perfect then. Thank you, Andrew. So
What about that
technically,
speed, though?
yeah. So when this is a big thing also when it comes to like repeated code and having like a inheritance structure like this. For example, you could go through and create 9 classes and 9 instances of the variable tail, right? Or you can just do it once at the very top and it trickles all the way down. It saves you a lot of work and a lot of repeated code. Not to mention it makes your interface a lot more readable as well, right? And also it'll make it easier for you to solve your problems because you won't have to, like, for example, like let's say when it like you write something that has to do with tail, like let's say you write a function like that has to do with how your tail grows or something like that, right? Obviously, in an actual scenario, it will be something a bit more complex, right? For example, if we go back to like the ice cream or freezers machine, like let's say you had something to do with like ice cream melting or something, and you had to work with like different like flavors of ice cream. If we wrote 8 different or 9 different tail functions, then we have to debug 9 different tail functions. Does that make sense? Versus if it's in one spot, it makes it a lot easier for us to debug our code. Okay. So in this case, we don't really want to use tail. Oh, for dolphin, right? What is something that is like unique to dolphins?
As a blowhole.
Andrew, I think I saw you first. What did you say?
the laugh or the noise that it makes.
What is the name of that sound? Does anyone know?
No.
Trying to think.
It's annoying.
I think they click. I think that's. I'll say clicky noises. Whatever. Can you think of anything else?
They use sonar.
Sonar. Awesome.
Whistles
Now-
and clicks.
What about sea lions?
Vicious.
Yo, they bark. That's for sure.
They do bark.
In terms of the animals here, they also have whiskers.
Yeah, so nothing else has whiskers here. They bark. Okay, so that's something else I want to say. When it comes to properties versus methods or functions. When it comes to properties, you want to think of something. Properties are more like the nouns, right? So like whiskers, they have they have 4 flippers, right? Stuff like that. Your functions, your methods, those are going to be your verbs. Okay, so in this case, our functions are going to be stuff like bark, swim, things like that. But obviously, swim we can apply to everything. So swim is something we want to put at the very top. Does that make sense? You guys get that? So what is another like method or like function you think you could apply to sea lions?
I guess the habitat we live in.
Be food chain. I don't know.
Yeah, I think that's the first thing that comes to mind is like how they hunt their food, right? Because obviously sea lions have a hunting technique that's a lot different from all the other animals on this list, right? Something like that. So we'll call it hunt, right? Can anyone think of like an example method for dolphins? Like any like verb word that you think? Just I guess technically sonar might technically qualify, but like anything else.
Type
Tricks.
of tricks we can do.
Sorry?
I guess navigate would be the verb for sonar.
Yeah, navigate would be good. Oh, that sounds all right. Okay. So now we got mammals. Let's try to figure out something similar for like the fish and the reptiles, right? But I'll let you guys do this like more on your own, just so you guys get more of a feel for it. So we have reptiles. What are some properties of reptiles?
You have scales.
Scales.
Cold blood.
What do you say? Cold blood?
Yep.
Did someone say that? Okay. What else?
They lay eggs.
Yeah, I guess that's true. They do lay eggs. So that's something we can apply to all our animals, because obviously the mammals don't lay eggs. Okay. Can anyone think of any methods or functions that are unique to reptiles?
They're poisonous. I don't know.
I guess yes, in a sense, but I don't think turtles are poisonous. I'll be honest, I can't think of any. So if no one can think of any, that's totally fine. We don't necessarily, in this case, you don't necessarily need to have, like inherited functions and or properties, but lots of times when you do have them, like when you have the ability to use them, you want to use them because they're going to make your life so much easier, especially like right now on the challenges you guys are working on, when you got like when you're working on coding problems that are like maybe 100, 200, 300 lines long, you could just code it all out and not even bother using OOP. But when you get to like really big projects where you're writing thousands of lines of code, like having an efficient structure will save you so much time, and it'll save you a lot of effort in the long run. Okay, so then what classes are we having inheriting from reptiles? What are our two child classes in this case?
Eel and turtle.
Oh, I guess just one. I think, are eels fish?
Eels are fish.
Eels are fish? Okay. So I guess it's not two, it's just one. So just turtle. What are some properties of turtle?
Shell.
Shell.
Shell, obviously, is the big one. Anything else?
Australian accent.
I guess it depends on the turtle, but I like the reference, Andrew. I appreciate the reference. Anyone else? Anyone else think of anything?
Amphibious.
Long life. Like they live to be over like 100.
Now I'm just thinking out loud here. Is long life something? I guess that would be a property, yeah. Because the turtle has a long life.
Lifespan or
Yeah, we'll say lifespan. That's good. Anyone think of one more thing?
Amphibious.
Well, technically they're reptiles, so they're not amphibious. But I guess they can go on land. But if you think about it, does the turtle have an amphibious? Right? That doesn't make sense, right? So if we're gonna use amphibious, where do you think we would use that?
I mean, the next part.
Right? Yeah, it's gonna be more of a method because it's something a turtle does. It's more of an action than it is a noun, right? It doesn't belong to a turtle. It's something the turtle does.
Just to be clear, it's just turtles in general, not like, I don't know, tortoises or sea turtles.
I was thinking more along the lines of sea turtles because this is an aquarium,
Okay.
but it could just be turtles in general.
Eat.
It's all technicalities, I guess, just for the sake of for the sake of the example, let's just make this a sea turtle. So we're consistent. Now I'm gonna see if this works. All right. Okay, never mind. This is annoying. We're just gonna call it a sea turtle. And then we said amphibious. Or we'll just say and go on land. Anyone think of any other functions that a turtle could do?
They
Ashley.
There are eggs.
Yeah, Ankur, what were you saying?
Oh no, I just had a question. When you have lifespan, is that just like a duration? And then if so, could that apply to all animals, or is lifespan just like a Boolean signifying as a
Yeah, that's a good point, Ankur. Thank you. So yeah, lifespan, technically, if we're going to be specific, every animal has a lifespan, right? So if we're going to call this lifespan, I think we should put it up here with everything else, right? But something specific to turtles, right? We said besides the shell, we'll just say or something like that, right? Because at the same time, it's slightly more specific to turtles, but not really. In this case, probably a more efficient way if you were to actually code this out, since every animal has a lifespan, right? You just give turtles a longer one. So you wouldn't actually need a second variable in this case. Does that make sense, guys?
Yes.
Yeah? Okay. Can anyone think of did someone mention another function that a turtle could perform?
They dig holes to bury their eggs.
Dig holes. Awesome. Okay. And then lastly, let's do fish. Okay, so properties. What do you guys think? A fish.
Gills.
Gills?
They usually lay their eggs in clusters.
I don't know what the I don't
Scales.
know what the specific term for that is, but yeah, lay their eggs in clusters. Did someone say fins? I heard fins.
Said scales.
Scales, I'm just gonna say fins. We already said scales for reptiles, but we can just say fins in this case.
They're
And
not
then-
quite donuts, but they are delicious.
I don't know if that's
You could put their friends.
I guess. Fish are friends, not food. That's
Yeah.
true. I don't know. Is that a property? Yeah, sure, fine. We can add it as a property of fishes. Fishes can be friends. I don't know how you quantify that in a variable, but that's something to figure out some other time. Okay. And then what are some functions that you guys think fishes perform, but all fishes perform?
Breathe water or?
Yeah,
That is-
breathe with gills, right? Guys think of anything else? Anyone?
I guess the ability to swim.
I guess, but technically doesn't everything in our aquarium have the ability to swim?
Swim could be like an aquarium attribute because they could go to all of the.
Yeah, that's a great idea, Alex. So I'm just gonna put this over here. Because every animal in our aquarium can swim. Right. Right now we'll just say breathe with gills, nothing else. And I don't think we want to go into all the fish. So let's just pick, maybe two. I'm gonna pick the clownfish just because of Andrew's reference earlier. And then can anyone want to pick another one?
Seahorse.
Seahorse? Okay, we'll do the seahorse. Okay. So, properties of clownfish.
Oh, they're funny.
They're funny. Okay, so let's think. Funny. Does a clownfish have a funny? Or is funny more of like a verb?
It's almost like an adjective.
Yeah, exactly. But I feel like we can rephrase this, right? And we can just call it something like, clownfish, they tell jokes.
If they appear funny or if they act funny.
You can say anything that, yeah,
They-
that's a good one too. They can act funny. Yeah, I'm gonna erase this real quick.
They have like a unique coloration pattern. Is that a thing that you'd ID down here in the clownfish class?
Well, let's think about that. So, yes, the coloration pattern that clownfish have is unique, right? But if you were to quantify it, right, we would like categorize that as just a coloration pattern in general, right? Which
Yes.
we could apply to a lot of other fish, right? We can
Yeah,
apply that
yeah.
to reptiles as well, right? So that is something unique to clownfish, but it's not necessarily.
It's the
Like-
poison resistance or the
Sorry, what do you say? Poison resistance?
yeah to the sea anemones.
Do we think that's a property, or is that a method?
It's a technically a property, but I guess it could be looked at as a verb as well to resist poison. Like however.
Yeah, I think it could be both, but in this case, I think it is more of a property.
Unless it's a defensive mechanism that's some kind
Yeah, unless it was, yeah, but if it's like a built-in resistance, then I think it's more of a property, right? Because a clownfish has resistance to an anemone.
But only if you roll high enough, right?
Yeah. But Jack, back to what you were saying earlier with the coloration pattern. It's the same thing with lifespan that we came across earlier. So the issue is when you encounter something that is shared by different classes, but in different forms, then in that case, you can use one overarching variable, right? In case lifespan, every single animal on this list has a different lifespan, right? None of them have the same lifespan, but either way, it's still measured the same, right? Does that make
makes
sense?
sense.
And in
Yeah.
this case, like every animal has a coloration pattern. They're all different, but you quantify it in the same way. Like you would quantify the coloration pattern in the same way, right? In this case, if you were to quantify
Yeah.
coloration, probably something with RGB and stuff like that. But that's the reason why I would be hesitant to put it inside just clownfish, because anything can have a coloration pattern.
Yeah, that may make sense. But
Yeah,
like,
and-
yes, it's a unique color, but that's not necessarily what you want to capture here. Like,
Yeah, and also, for example, let's say you only care about the coloration pattern of clownfish, right? So you're like, oh, I only care about clownfish, so I'll just put it in clownfish. In that case, you're still better off putting in the in the parent class. So let's say, for example, you put in the parent class, you only implement it like for clownfish, right? Everyone else, you just leave it blank. Now, if someone else takes a look at your code, let's say another developer or like a partner or someone else on the line, let's say you work in this code and then you decide to, switch careers or switch jobs, you go to a different company. And then like 10 years later, someone else sees your code. Since you already have that built in, it gives the program more flexibility. So they can go in and they can add coloration patterns to everything that they want, right? Even though you didn't want it originally, it makes your code a lot easier to use for other people as well, like not just for you. Which is why having these structures like laid out is super important. So a lot of times when you're going to be using object-oriented programming, when you're going to have some kind of class hierarchy with with functions and properties and all that stuff, I find it a lot really helpful. Obviously nothing as like detailed as this, but like I draw like a simple tree and try to figure out what relates to what and what's a property and what's a function. I find it makes it a lot easier to have that plan all out before I even start coding. That way I don't have to backtrack. I don't have to write repeated code and all stuff like that. Yeah. And before I want to just wrap this up so we can pass it on to Rena. What are some properties of seahorses? Can anyone name any?
The male usually gives birth.
Males give birth. Okay. So giving birth.
They give live birth.
What'd you say, Don? Sorry?
Are we saying they give live birth rather than lay eggs?
Technically seahorses lay eggs, right? But the females just lay the eggs inside the male and then they hatch inside the male. But so I still think they qualify under that lay eggs for fish. But I was just asking, is giving birth more of a property or is that
method
more of a function?
Well, storing eggs for the male would be a method.
Yeah, right. And I still think giving birth also would be a method, right? Because it's more of a verb, it's more of an action. So let's move that down here. Now, what about properties? Can anyone think of a property or two of seahorses? Anybody? I'm sure someone can think of something.
Well, everything I'm thinking of is gonna like fall into the same trap of like pattern, right? It's like they have a unique shape, but that all these things have a shape, and again, we're kind of back into what we just talked about.
Don't they have a pouch?
They do have a pouch. Also, Jack, when you think about when you're thinking about like those patterns and stuff, don't get too wrapped up in that. Just look at it in the context of these 9 animals. So what is something, and also it's okay if a seahorse has it and a sea lion has it, right? But because like the issue is if a seahorse has it and a sea lion has it, but no one else in this entire list has it, then we can't put it at the top, right? Because then what's the point of inheriting it down if only 2 of the 9 people can use it? Does that make sense? At that point, you want to split up your vote.
It's like a design decision thing where it's like this is only gonna be used in a couple spots. It's okay because that a reason. Okay,
got it. So seahorses have pouches. I think James said that, right? Can anyone think of one more? I'm trying to think of any myself.
I don't know anything about seahorses, so I can't even tell you.
That's true. That's true. I was gonna say,
They have a curly tail.
yeah. I'm trying to think. We said technically up here everything has a tail, right?
Curly is an attribute then.
Yeah. And I think if we inherit it down, we can obviously specify, because everything has a different kind of tail, right? So I don't think having a curly tail is something that's specific to just seahorses in this case, right? Well, obviously having a curly tail is specific to seahorses, but having a tail itself is not. I don't know. We could just do something like,
They don't have scales. Instead, they have hard, bony plates covering their bodies.
plates. There we go.
you solved the puzzle, Andrew. Thanks.
Good job, Andrew. Did you get that from SeaWorld too?
That's from oceanconservancy.org. Yes.
Awesome. Always cite your sources, guys. But yeah, so this went a little longer than I thought it would, but I hope, and I know it was like a bit like fundamental, a bit rudimentary, but I hope it kind of helped you guys clear up like why it's important that we have these hierarchies, and then where do we use, right? Where do we use like an inheritance structure? Where are we going to use a property? And then where we're going to use a function, right? I hope that helped you guys kind of understand like the basics of how that works. Again, when in doubt, just use the is a, has a, and then noun versus verb, right? If it is a, then it's an inheritance relationship. If it has a, then it's a property relationship. If it's a noun, then that means it's going to be more of a property. If it's a verb, it should be more of a function or a method. Okay. But I'm going to go ahead and pass it off to Rena, and she's going to do something a lot more fun. But I'll let her explain that to you guys.
Thanks, Ash. So hopefully the inheritance hierarchy was really clear in Ash's example. We'll be using this a little bit in my example, which is slightly more complex. I'm gonna go over, oops, what am I sharing right now? I'm gonna go over how we might design the game of Pac-Man. Can you all see my screen right now?
Yes, ma'am.
Okay, so for those of you that aren't familiar, okay, so for those of you who aren't familiar with this game, it's an arcade game where the user controls Pac-Man, which is the little yellow thing. And the object of the game is to eat all of the little dots and run away from the ghosts. If you get eaten by a ghost, you lose a life. If you eat one of those big dots called energizers, then the ghosts go into frightened mode and then you can eat them for extra points. Obviously, you want to get as many points as possible whilst also not dying. So We just wanted to place a lot of emphasis on sort of designing your code before you begin writing. It's really important to have a strong foundation. Otherwise, later on in the coding process, you might find out that, oh, I should have put this method in this other class, or like I should have included an instance of this object in this other class, and you might end up with a bunch of like accessor and mutator methods that can get really messy and clutter your code. So I guess right off the bat, what are some things that you can see on this board in this Pac-Man that you might want to create objects for? Or
You have the map.
Exactly, yeah. So we have a map, a board,
Score, lives,
board.
Enemies.
Yeah,
The ghost.
character, the different characters, enemies, and yourself.
Little fruit bonuses.
Keeping score.
Hit boxes.
The dots, both the normal ones that you go through and the special dots.
Mm-hmm. Yeah, we have walls, we have free spaces, we have 4 different ghosts, so this might be a good idea to implement inheritance. We could make a ghost class, and then we can make separate classes for each of the individual ghosts. Yeah, okay, so we just listed out a bunch of objects. Now let's try to organize them in a way that makes sense. So can everybody see my whiteboard?
Yep.
Perfect. So at the very top, we might have our app / our runner class. This is the class that you'll run in your terminal. It would probably be a good idea to also wrap everything inside a game class that'll handle all of the logic. And then from there, does anybody have a proposal for how we should organize all of our ghosts, our Pac-Man, our board, our dots, etc.?
Make a board class, or would that be under game?
Board class sounds good to me. So these arrows just kind of represent what class holds an instance of another class. So in our app runner class, we'll create an instance of the game class. In the game class, we'll create an instance of the board class. So one thing I want you guys to think about here is which objects need to know about other objects. So most obviously, we would probably want our board to be able to keep track of what's in it. So like if one board piece has an energizer, or if it has Pac-Man, or if it has a ghost in that particular location, we would probably want our board to be able to keep track of that. Let's write a little note here. So I actually coded this for one of my past projects. So I know that the board is a 23 × 23 grid. So what I have in green will be properties of a class. And then after we fill that out, we can move on to talking about, oops, methods of a class or capabilities of a class. Okay, so what else?
Maybe a character class to deal with any moving parts.
Sounds good. We can have a character class. And what do we put in here?
You got the ghost and then your player.
Actually, before we move on, what are some similarities between our ghosts and our Pac-Man that would warrant a shared class? Because we wouldn't want a wrapper class that doesn't really have anything in it.
They're like the same grid size.
What do you mean by same grid size?
So the character Pac-Man and the ghost are like basically both squares moving on the grid. So they'd have the same pixel ratio.
Okay, that could be one thing in common.
Movement
You mean hitboxes?
ability.
Sorry, was that Stephen? Could you repeat that?
Does he mean hitboxes?
Head boxes?
Hit.
Hit.
Collision detection.
Collisions, yes.
The characters have position on the board.
Okay, so our ghost is a superclass. And then within our ghost class, we have 4 different ghosts. I believe they're called Inky, Pinky, Blinky, and Clyde. Okay. What about our dots and our energizers? So our little dots and our big dots, where should we put those?
Can you put that in the board class?
What if,
A subclass of the board?
so let's think about some things functional wise. We know that when Pac-Man eats a dot or an energizer, we want it to disappear from the board. We also want to be able to increase the points when a dot or an energizer is eaten. So where should we place this so that we have like some bigger logic and we know like
Maybe
where
Like a
Pac-Man
utility, like a utility class.
or expendable class, so it can include the fruit things as well.
The Energizer is either a subclass of a dot or it's just properties of a dot.
Yeah, I can see how an energizer could work as a subclass of a dot. The only difference is that you would have to have the ghosts turn into the blue mode when an energizer is eaten, which wouldn't happen for a regular dot.
Which relates to ghost, not the dot.
Sorry, could you repeat that, Don?
What happens to the ghost relates to the ghost, not the dot, and the dot disappears whether it's an energizer or a regular dot when the ghost reaches it.
Right, but how should we keep track of when a dot is eaten so that we can tell the ghosts to change their mode?
That's a property of the dot.
Can you elaborate on that a little bit? So when a dot is eaten, we know that it wants to disappear. So how should the dot communicate to the ghosts that we want the ghost to shift modes when a big dot is eaten?
You could set it equal to a Boolean, and then when it reaches that location, then you could turn it on to true, and then in which case it'll disappear.
Yeah, so we would want to have a class that has instances of both of those things. Otherwise, you can't really communicate directly because it doesn't really make sense for a dot to have an instance of a ghost or a ghost to have an instance of a dot, just because those aren't really properties or capabilities of each other, if that makes sense. So personally, I would probably approach this by putting the dots and the energizers also under the game class in the same level, so that the game class can sort of keep track of where everything is and respond appropriately to all sorts of different scenarios. Does that make sense?
Makes sense to me.
Yeah. Okay, was that everything we said? We also had a scoreboard, let me add that.
And you've got the little bonus goodies. The cherries and such.
Yeah, the cherries. We can also group that under like special cherry bomb. Okay, so this structure looks pretty good. Let's move on to some of the properties and the capabilities of each class. So we can start with Pac-Man. So what are some properties of Pac-Man? What is Pac-Man? Well, it's yellow.
Okay. It's yellow, yes.
And when I say properties of a class, I mean like what would you want to put in its constructor method or its init method? Like when you create an instance of Pac-Man, what do you want it to be before it even like does any of its capabilities?
He's got a life count or like a certain set amount of lives.
Yeah. Remember,
Got a mouth.
got a mouth. Yeah, you can do the animation for that.
Starting position.
Yes, perfect.
I guess the sprite.
Sorry, Steven.
I guess the sprite of Pac-Man.
The sprite.
Yep.
What does that mean?
Like the image.
Image.
Got you.
More general than the starting position, we have his position.
Yep. And this is probably something that your game can pass in when it's initializing Pac-Man. Your game class can tell where you want your Pac-Man to spawn at the very start of the game. What are some capabilities?
Each of the dots in the ghost.
Can you repeat that, Tim? It can eat things?
Yeah.
Eat dots, ghosts.
So are the purples the method?
Yeah.
Rena, can I include one thing real quick?
Mhm.
Yeah, I just want to say something like I think Don mentioned about the starting position. In this case, if you think about it, Pac-Man does not actually dictate his own starting position, right? The game's what's deciding where Pac-Man starts, which is why while having like Pac-Man's position itself, which is something he's in control of, right? So his current position is something you'd want to have inside of Pac-Man, but the starting position is something that you can put like further up the hierarchy towards like maybe either like board or game or something like that, because that's something that the game decides and not what Pac-Man decides. Does that make sense, everybody?
Yep.
Current position. Let's change that up. Thanks, Ash. Yeah, what else?
He has a method that allows him to move left, right, up, down.
Move, yes. Respond to
I guess to add on to that, movement speed.
speed. I don't know if that's actually a thing that you can do in Pac-Man, but I'll put it down anyway.
Because I assume like the ghosts each have their like different movement speed and stuff like that. So unless they're like all the same throughout.
I think all the ghosts have the same speed, but when they're in blue mode, they're slightly slower.
Gotcha.
Yeah.
So I have a question for everyone. So like when it comes to speed, is that something that you think is unique to Pac-Man?
Move and speed could be in character.
Well, can the ghosts, do the ghosts respond to keyboard inputs?
No.
Next question.
Random.
There are times that the ghosts change speed, but Pac-Man stays the same.
Yeah, but if you think about it, both the ghosts and Pac-Man both have movement speed, correct? Even if they're different amounts. It's in the same case like that lifespan we talked about earlier with the turtle. So even while they're different, all the characters have a speed. So speed could be something that we would want to put under character versus like under Pac-Man or under Ghost. Does everyone get that?
Yep.
Okay, let's move on to our ghost class. What are some properties of the ghost?
They go blue mode or whatever it's called.
Scared, frightened mode.
So
Like
these are
They become
capabilities.
edible.
Let me put them in turn to blue mode.
They chase Pac-Man.
Chase.
So a hunt mode.
Okay. What are some properties?
Color?
Yep. So each of the individual ghosts are different colors.
Don't they each have like a different kind of like chase logic for going after Pac-Man?
I wouldn't be surprised if some of their algorithms are stronger than others. In my case, I use the same algorithm for all of them, and the reason why they didn't all take the same route is because they spawn from different parts of the map. But I used a BFS algorithm to chase Pac-Man. And then I believe my blue mode was just like take random turns. It wasn't even like run away. But
You'll avoid collision though.
avoid collisions?
As the ghosts avoid collision with each other.
Do they avoid it?
Um,
I'm not sure. I haven't played Pac-Man in a while.
I believe they do. I think they just run through each other.
I think they can run through each other, yeah.
My memory's not that good, but I'll bet you I played Pac-Man before anyone else here.
We don't doubt that.
There's articles on how the ghosts move. If you want to get into it being authentic to the original game, if you care that much about it, they have a chase mode and a scatter mode based on whether or not they're blue. And each of the 4 ghosts have a different movement pattern. In scatter mode, they each try to move to one of the 4 corners.
Mm-hmm. Okay, we can move on to our dots energizers class.
And I actually looked into it. It seems each of the ghosts do have a different like tracking pattern for following Pac-Man. That's kind of interesting. If anyone wants to look
different.
It's a lot more complex than I thought it was, in all honesty.
Yeah, at least one of them try to like cut Pac-Man off, so they like target the square like 2 in front of it.
Yo, so they're legit hunting in a pack. Yeah, a method for the energizers would be they turn the ghost mode on.
Turn on ghost mode. Yeah, so the dots and energizers can, like, you could have a method that returns true if like an energizer is eaten, and then your game class could use that to tell the ghosts to turn blue. That's one way to implement that. Let's expand a little bit on the board class. So we know that a board is made of 23 times 23 squares. Maybe it would be useful to have a board square class. So our board square class could be a number of different things. It could be a wall, it could be a free space. And then this class could also be in charge of knowing what it contains. So whether or not it contains a dot, whether or not it contains Pac-Man. These are all things that are useful for your logic in your game class. Does anybody have anything else to add?
You could maybe include some of the effect of like orientation so that you only have to have like one corner and then you just determine how it's rotated.
Can you
like on the map?
a little bit on that?
Yeah, so like you have like a corner, and then having the top be able to be orientable so that you can like have that same corner be in different spots rather than needing like a top left corner, a top right corner, or is that am I off the mark here?
You can flip it 180, you can't rotate it.
Yeah, I think because each square is such like a pretty primitive construct, you don't need to worry too much about optimizing it so you can reuse the same square because you can easily just spawn 23 times 23 squares. Did that answer
Okay.
your
Yeah.
question? If I got it right. Okay. And then our last class, we have the scoreboard. What are the properties of a scoreboard?
Points,
Points, exactly.
lives,
Yes.
maybe time. I
Points
don't
and
know.
number of lives. Yeah, time elapsed.
The level.
Level. And then our methods would just be increase or like decrease, all of these properties. So a lot of the scoreboard methods will probably look like set points, set lives, get points, get lives, accessor and mutator methods. Yeah, this looks pretty good. Does anybody have any questions so far? Okay, so I have a couple challenge questions that I want to tackle. So let's say one functionality that Pac-Man has is that when it goes off the board, it appears on the other side. So where might be a good place to implement this? So like what method and what class?
Probably under the game class, since it's keeping track pretty much the scoreboards and whatnot. And then also, since it's under the game, it could tell the ghost that he went from left to right or right to left. And so that would be more of a method than a property, I would say.
Okay, yeah, so it should definitely be a method since it's an action. There are definitely multiple ways to implement it. I think I actually put it inside my Pac-Man class. So if it was just moving in the directions towards off the board in one of the edge squares, I would just relocate it to the other side in the next time step. But I think you could definitely include it in the game class. That also makes sense to me. Okay. My next question is, ghosts spawn from the ghost pen in the center of the map. How might we implement this?
Sounds like the ghost pen's an object of the board.
So our game keeps track of an instance of board. And then when we initialize our ghosts, we can tell it to have its start location from within the ghost pen. And then we can also tell our board that those are the locations of the ghosts. And this is a very similar question, but when Pac-Man eats a dot or an energizer or a cherry, it disappears from the board. Where would be a good place to implement this functionality?
In the game class?
Or a property of the dot.
Yeah, like it might all be all the way down in board square potentially.
Do you want to explain why you think that, Jack?
So board square is tracking what is inside of it, and so it knows when Pac-Man enters it, and it knows if it has like a dot, and so Pac-Man eats dot in board square, and that might be a good place to do that methodology because it's already kind of handling that information anyways.
Yeah, so you can continuously update your board squares to reflect what's in it. So when you tell your board square that, oh, this energizer has been eaten, then you can visually remove it from that particular square. Does anybody have any other functionality questions? Or any of the TAs have any challenge questions?
Is a dot a child of a board square?
I think that's definitely one way you could implement it. In our structure here, I think what we're aiming for is to have the game carry multiple instances of dots and energizers and just tell the board where those should be. Does that make sense?
I think you might run into some issues with that because we considered the cherries and the fruits under dots and energizers. So if you wanted to move that, you would have to move board squares as opposed to just moving the location of the cherry.
The board squares can always stay the same in terms of the actual object. It's just the things that they carry within them that change. So you'll never have to like swap around two actual instances of board square on the board. You would just change what's displayed on it. So like, for example, each board square could hold an array of dots, energizers, Pac-Man, ghost, anything that can appear on that square. And then when it updates, you just want to make sure that visually you take away or you add that thing onto that particular board square.
It sounds like you're making an argument for dots, energizers, and cherries being children of board square.
Yeah, I can get back to you on that. Let me double check how.
We don't have to decide one way or the other.
Yeah, I think there's many ways to skin this cat.
I don't think we're going to finish this project.
Don, I think you're actually right. I don't think we went over interfaces in Python, but it's essentially not a is a relationship like a superclass is, but an as a relationship. So things that are quite similar on a broad level, but specifically implement things in different ways. So I think I have each of my board squares hold an array of collidables, and my collidables are dots, energizers, and ghosts, things that Pac-Man can eat, essentially. So yeah, that was a good point that you brought up, Don. Thanks.
The whole idea is for us to not necessarily get it right, but think about it, right?
Mm-hmm.
Also, when it comes to problems like this, there's no one right way to do this. There's always like ways that are more efficient and ways that are less efficient. But obviously, efficiency is secondary to understanding. If you don't actually understand how you're solving the problem, there's no point in making it efficient. So obviously that should be your, like, always go with the way that makes the most sense to you. And then once you've established like how it makes sense, then you can go about making it more efficient. Does that make sense, everybody?
Yes, sir.
It's almost, yeah, pretty much.
And it's like especially important when it comes to problems like OOP, which require a lot of like background, like planning and thinking before you actually start any coding.
Okay, well, hopefully this made sense and cleared some things up in terms of how you should go about designing your classes, class hierarchies, what sort of instances you want to store in different classes to achieve the desired functionality. If you are interested in looking at the actual implementation, let me know on Slack. I can definitely send you those files. Yeah, also hang around on the breakout room if anyone has lingering questions. But for now, I will pass it on to Kate.
Thanks, Rena. Wait, how are you doing on time? Because I don't know.
It's been around an hour. So I guess if some of you guys want to go do challenges, like you can, because we're going a little bit over time. But I know Kate has a really good example, and if you guys want to stay for that one, I 100% recommend it for everybody.
Yeah, I don't think we're pressed on time. We're probably going to have stand down at 4 o'clock. Just again, starting early. I would highly encourage everyone to stay with the breakout room. I think it's great material, but I would suggest taking a quick break just because our presenter's been going for an hour. Obviously, the audience might need to stretch their legs, so maybe take like a 4-minute break, and then Kim, Kate, would you be ready at 2:40?
Yep.
Do people accidentally call you Kim all the time, or is that just me?
It happens a lot.
All right, sorry about that.
I do it too sometimes.
All right, see you guys in a few minutes then.
Thanks, Alcor. So I'm Kate, and I'll be walking you guys through our last exercise for today. It's called the bike rental system, and as developers, we're trying to make a system that allows customers to rent bikes from a bike shop. So before I get started, I'm going to share my screen. Can you guys see my screen?
Yes.
So before I get started on any problem, it's an iPad. Before I get started on any problem, I like drawing out the components of my system, so it's visually easier for me to picture what classes I might need when I'm coming up with my code. So I'm going to attempt at drawing a bike shop. Feel free to chime in because I'm going to be drawing like what goes inside a shop, a real life bike shop. So first, they will have a bike rack for all the different bikes that you could rent. I don't know how to draw bikes, but I'm just gonna draw like 3 little bikes just for visual guidance. And then what else would a bike shop have?
Tires.
What?
Tires?
Tires?
Yeah, like other components of a bicycle, like parts.
It's a bike rental shop.
I need a helmet to go with my bike.
Oh, yeah. So they would have little helmets for rental as well. It will also have a cash register place and a person to take your orders and a cash box. What else?
A log book of, I don't know, just transactions and what you have in store.
So they'll have records of who borrowed what at what time. They'll also have a poster or a sign for all the prices and also the open hours of the shop so that customers can know when to come back when the shop is not open. So I think this is it for the shop. Another thing that we have to keep in mind of is there'll be customers outside the shop waiting to rent some bikes. So I think that's all that we have so far. And now we're going to come up with the interface system. So basically representing this person here. And we can picture that that person's like an AI. So they can take whatever commands the customer orders them to do. So we would need an interface to handle all the different commands. So what this would essentially do is it would need to print the menu. And this is kind of similar to the ice cream example exercise that we did earlier in class. So it would print the menu and take the customer's orders. What kind of, I guess, methods would the customers benefit from that the interface should have?
Like to view a list of all available rentals.
So check the availability of bikes.
How much it would cost, maybe?
Yeah, if there's like a pricing consideration, or if it's just a flat rate, you know. But what is the price either buy the bike or in general?
This is the employer using this, or this is the customer using this?
The what?
Is the customer using this interface, or is the employee using this?
Oh, the customer is. So we would check the prices.
Being able to
Want to make reservations as well.
Yeah. It would help to be able to make reservations. And obviously rent bikes or make payments.
You get through it after a while.
Oh, what was that?
Yeah, return it.
Wait, sorry, I'm gonna. Okay. What was that? Sorry. We also have to be able to check open hours. Of the shop, and this wouldn't be for customers, but just for debugging sake, it would help if we could check the total profit that the store made.
You're
So
also
that-
going to need a method for the customers to turn in the bikes when they're done with them.
Mhm. So that could go under the make payments. So they would be able to pay when they return the bikes. And then obviously we would need a quit option so that the loop would end when the customers want to leave or stop talking to the interface. And so as we list out these commands, it's important to make notes on the side when you realize that you need a certain class. For example, for number 1, we have check availability of bikes, and we know from this command that we need a class bike, and that the bike object will have to have an attribute of availability. And that would have to be something that we can change. So it will be a variable, not a constant. And also, it would be helpful when we check the open hours to include a detail, like when the store is not open, customers can't rent bikes. And anything else that you guys have noticed?
You're gonna have to update the availability of bikes.
After they rent them, yeah.
Yeah, or turn them back in.
So you would need to update the availability and also increment the profit of the shop. And then I think that's it. So now that we came up with all the different commands that the customers can choose from, we're going to come up with the actual classes that we need in order to code our system. So first, from this picture, we see these separate elements. So it's easy to tell that the shop is separate from the customers. And one thing to note here is that when the customers are using the interface, but we don't need to store any information about the customer, then we don't necessarily have to have a customer class. But since we do need to make reservations and store their name or their phone number, it's necessary that we have a customer class. So we'll have the customer class. And then what are some attributes that we might need to store?
Name, address, time they checked it out, time they're supposed to turn it back in. Maybe a phone number.
Yeah.
Credit card information.
And one thing to note here is that whenever you create the attributes for your class, it has to do with like reservation or storing the customer's information and differentiating one customer from another customer. It's important to have at least one attribute that is unique to that customer. So for example, name is not gonna be a unique attribute because I'm Kate Kim, but another person named Kate Kim can borrow another bike, and then it will be hard to differentiate between this Kate Kim and the other Kate Kim. So if you're going to associate the customer, one attribute of the customer with the bike, it's important to use a unique variable. So in this case, the phone number is a unique variable. So it will work to have these attributes for the customer. And then we would need to come up with a shop class. And can anyone list any attributes that the shop would have?
Inventory.
Of the bikes?
Yeah.
Yep. So that could be an array of bike objects.
You're gonna need shop hours.
And unlike the inventory of bikes, shop hours is going to be constant because it is needed only for viewing. And you're not going to, as a customer, you can't change the open hours of the shop. There's also price listings. And that will be constant as well. The cash box. And this would be variable because you can increment every time a customer borrows a bike. Anything else? If not, we can move on. So now we have to think of how to store these different attributes. So we came up with the customer and the shop class, but we still don't have the bike class or the bike object that is needed for the inventory. So we could also make the bike class, and this would also need a unique attribute in order to differentiate from other bikes. Can anyone think of any unique attribute that can be associated with a bike?
Yeah, like a two-seater,
The what?
like a one-seater or two-seater bike.
Oh yeah, so the type.
Yeah, I said serial number, but maybe that's too specific.
Oh no, I think the type is still not really unique to the bike itself because you could, in this example, I only drew like 3 bikes, but this could be like a bike shop with 300 bikes, and they might have a lot of different bikes with the same kind of attribute. So like they might be the same type, but their serial number will be different. So the serial number could serve as the unique attribute in this case. What else? There's color and availability. And for availability, what type of variable do you think this should be?
That could be binary, but it would be good to have the expected time of return.
So by binary, do you mean like bool type?
Boolean, true and false.
Yeah. So this could be a bool type. And yeah, I think that's everything so far. And then for when we make our shop class, we have these like constant variables, right? And we can store this inside a dictionary when we initiate our shop class, because as a customer, you can't really customize the open hours or the price options. So it would be like a preset dictionary that you would put inside of your shop object when you initialize it. And then another thing is, I guess I'll give a little example of how these dictionaries could look like. So the open hours could look like this, and you could have like Monday and then a time. So like 12 to 3, or I guess this would be, this would be 15. And one thing to note, this is just a little tip on the side, is that Python has a module called datetime. And it allows you to basically calculate the time, date and time right now, or create your own date and time variable. So for example, you could do like right now is date time dot date time dot today, and then I believe it will return like a object like 2021. What day is it today? Is it the
18th?
It's Friday.
Yeah. And then I'm just gonna come up with a random time. And then, so this is, I believe, milliseconds. And then this is like seconds, minutes, hours, date, month, and year. So you could use this as well to create your dictionary. And there's another method called like weekday, and then you can find out what day of the week you are on. So any questions so far? If not, then I believe that's it for me. Yeah. Hope that was helpful. And obviously, as Ash and Rena said, there's no right way to design this. It's just drawing it out and coming up with these different organizational skills. It's just helpful for you to code later on. And yeah, like someone else could come up with a more efficient way to solve this problem or to organize these different classes. But yeah, hope that helped.
Thank you, all three of you. Well, I guess 4 because Ankur's here too.
I'm just observing. But yeah, those were great presentations. Again, OOP, complicated topic. Glad. No, I listed the right thing, Alex. Don't worry. Or maybe not. Anyway, yeah, complicated topic. So definitely we'll take some time to kind of master. I can't even say mastering is a accurate state, just getting better and better at it. So keep practicing, especially if you're retaking assessment 1 or 2. I guess assessment 2 is more OOP centric. Then yeah, just keep practicing. Again, it's an important topic. We like going forward, we're not going to use OOP that much. It kind of comes up in Django and React development, but we don't, it's not going to be as hardcore as it's been, but it is a very important concept, especially when you get into interviewing. A lot of companies will, test you on it. And when you get into the industry, like obviously you're going to be in an environment, hopefully where your coworkers are going to, be helping you learn the technology and learn their software base. But most people are not going to be, teaching you OOP when you get to the industry. Like they're going to expect you to know it or know how to apply the principles at some level. So yep, keep it in the back of your mind. Don't feel bad if you're still kind of like, all right, I still don't have these design skills. Obviously, our TAs have had more experience with it and did a great job kind of sharing their knowledge base. All right, guys. So 3 o'clock, we'll be meeting back in the main Zoom room in an hour. So take the next hour, do whatever you feel is best.
I do want to say, Ankur, I'll also include one last thing before everything. I just want to do another quick reminder to everybody. So I know like today was more like designing solutions to problems. If you guys do want, again, I know it's like a broken record here, but like if you want a more in-depth approach to OOP and like why we need it, an actual like a more like hands-on actual code kind of approach to it, then totally come to Saturday's lecture at 12. Totally optional, but I 100% recommend it to you guys. I also don't want to be the only one there in the Zoom room by myself on Saturday. So if you want to keep me company, also show up. But yeah, hope to see you guys there.
Can you do a Slack reminder? It's like an hour beforehand.
Yeah, for sure. I'll definitely include a Slack reminder.